All right, so last section we are going to look at is 9.2. We'll split it up into 2 days. The first part we'll do today, and then the second part we'll do tomorrow. So up until now, all the graphing we've done, whether it's been regular function graphing or parametric, it's used an XY axis coordinate system. And we saw that with parametric, you can do a lot more kinds of graphs than we're used to. You can still do everything that you know how to do. Everything that you've ever done before, you can do parametrically. Plus, parametric does even more. Now, we're going to look at a coordinate system that gets rid of the x and y axis. Okay? It doesn't use that. It's going to use what's called a polar coordinate system. And what I'm going to do is I'm going to draw the same shape. I'm going to do it 3 different ways. I'm going to do it as a function. I'm going to do it parametrically, and then I'm going to do it with polar. Each system has kind of its advantages and disadvantages. If you've got to graph straight lines, then function is the best mode to use. Just y equals mx plus b, very, very simple. If you want to draw a straight line in polar, it becomes very complicated. It's not easy. I mean, it's not that hard, but the equation for it to draw a straight line involves trig. Right? There's no reason you need to use trig if you just want to draw straight lines. Just stick with y equals mx plus b. All right. So in a polar coordinate system, that's what your graph paper looks like. The center, they call the pole. You can still call it the origin, but it's also referred to as the pole. And this axis right here is the only axis. Okay, that's called the polar axis. So in polar, generally they do not refer to a vertical axis. There isn't one. They only refer to that horizontal axis, and that's the polar axis. Okay, so what I want to do quickly is I want to draw a circle. Right? And I'm going to draw it 3 different ways. I'm going to do it as a function, I'm going to do it parametric, and then I'm going to do it in polar. Okay, so we need to pick a size circle we're going to work with. Okay, let's do a circle of like radius, we'll do 3. Yeah?
Circle can't be a function because it doesn't pass the vertical line test.
Right, a circle is not a function. It does not pass the vertical line test. So for me to even try to draw it as a function, I'm going to have to do something special. Yeah. So the equation, let's start with function. Equation of a circle is x squared plus y squared equals r squared. If I solve that for y, I would have to subtract the x squared to the other side and then take the square root. And the reason I'm solving it for y is because if I don't, I can't graph it. I need y by itself to type it in on the calculator. And remember, when you take the square root, there's a positive square root and a negative square root. So let's put that in, and I'm going to let r be 3. I want to draw a circle that's a radius of 3. So let's go to function. We're going to type in square root, second square root. If we plug in 3 for r and we square it, we get 9. Okay, so that's part of the square root. And you also have the negative. Negative. You know what? I'm going to show you a different way you can type it in. I could type in the negative square root of 9 minus x squared. Or I just need to type in the negative of y1. Okay, and I can actually put that in. You can press negative, press variables, go to y variables, and go to function. So rather than having to retype that whole thing, I can just type in the negative of y1. So now I got the positive square root of 9 minus x squared and the negative square root of 9 minus x squared. Okay, let's do zoom 6. And it's not really going to look like a circle because the screen is rectangular. But I can make it look a little bit better if I do zoom 5. But that's as good as I'm going to get. That's all I could do to draw a circle with radius of 3 as a function. Okay? And it's not even really a circle. It's two separate pieces just kind of stuck together. So that's what you get. And that is what you have to type in to do it. Let me zoom out a little bit. Okay, any questions on that one? That's the function. All right, next one we're going to do is parametric. Okay, so in parametric, we've got two equations. Can someone remind me, when you are drawing a circle, what's the x equation for your circle? Yep.
X equation, x equals 2.
X equals what? It has trig in it. Yeah, it has some trig in it, yep.
It would be r cosine of t.
T. And what's your y equation? Whoops. Not r. Y. Yep.
R sine t.
R sine t. Okay, and we're going to do it again for the same size circle. I'm going to do a circle of radius 3. So let's go to parametric. Go to y equals. Put in, radius 3. T, cosine t, and 3 sine t. All right, now I do have to set the window. Okay, x mins and maxes are already set. What should I use for my t min and t max, given that I'm in radians and I want to get a full circle? Yeah. We got to go 0 to 2 pi. And if you're going to go to 2 pi, an increment, a t step in terms of pi is probably a good way to go. I would say let's go by like 0.05 pi's. Right? That should be pretty good. Window, we're going to keep all that the same. Hit graph. There you go. Okay, so what's the advantage of, or how does that picture compare to the previous picture? What's better about it? What's worse about it? Yep.
It's one continuous line instead of two separate just pieces.
Yeah.
And it goes all the way around instead of moving out little bits and pieces.
Yep, so it actually connects. It looks like a circle as a function. Remember, functions fail the vertical line test. I can't really draw a circle in function mode. But parametric, I definitely can. Okay, so that's parametric. Okay, and the last mode we're going to look at is polar. All right, so polar, we haven't seen that mode yet. So I go to mode. I'm going to go to polar. I'm going to go to y equals, and I'm going to type in 3. That's it. Just a 3. Check my window. I don't have a t min, t max, and t step. I have a theta min, max, and step. Okay, because now the variable when you're dealing with polar is theta. It's not t. So 0 to 2 pi, that looks good. That's not a good theta step. That's, if you count, that's pi over 2. So if you go from 0 to 2 pi, counting by pi over 2, you're not going to get enough points. Let's do 0.05 pi, just like we did before. And hit graph. All right, so there's my graph. Again, looks just like parametric. But what's a lot simpler this time is the equation. Okay, you go to y equals, or not, sorry, y equals it's the y equals button, but now it says r equals. It is much, much simpler. And that's really what Polar does very well. It's designed to graph circles very, very simple. Lines we can do in Polar, but they become more complex. So maybe at some point we'll look at a line in Polar, but for now I just wanted to show you the difference between the three systems. So in Polar, it's just r equals, and then you put your number on the other side. Okay, so look at the big difference with how you write the equations. In function mode, you're using x and y's. In parametric mode, you're using x and y's. In Polar, you're not. You're using an r. Right? So when you write a coordinate in Polar, you're not going to have an x and a y anymore. Okay? You're going to have two things, and one of them is going to be an r. Okay, let's look at what the other one is. It's theta. So in Polar, the coordinate still has two numbers in it with a comma. But the first number is r, and the second number is theta, which represents an amount of rotation. Okay, so every point that we graph in Polar is based on a distance from the origin and then an amount of rotation on a circle. Okay, in order to graph a point in Polar, the r is pretty similar to x. Okay? R basically tells you to either move left or right, starting from the pole. If r is positive, you're going to move from the origin to the right. If r is negative, you're going to move to the left. So r tells you basically left or right movement. Now, theta is an amount of rotation. When we describe rotation, you don't describe it with the words left, right, up, and down. How do you describe the direction of a rotation? Yeah?
Clockwise or counterclockwise?
Clockwise or counterclockwise. So depending on whether your angle is positive or negative, you're then going to rotate clockwise or counterclockwise after doing step one. That part's kind of like an XY coordinate. You got to do the first number, get to that point, and then you look at the second part of your coordinate, and that tells you to do something else. So the first number tells you to move left and right. Second number tells you to rotate clockwise or counterclockwise. So what we'll do is we'll just practice graphing some different points. I don't even think today we're going to get into polar equations. We will tomorrow. But for today, we're just going to graph single points, and then we'll practice converting between a polar coordinate system, and Cartesian. And so polar is r theta, Cartesian is x, y. Okay, so let's try graphing this one. It says 3, 45 degrees. Now, on the test, the graph paper is going to have a little bit more detail than what I drew. It's probably going to look more like that. Different graph paper can be set up differently, but this one is set up in increments of 15. So this is 0, that's 45, and that's 90. Okay. As you rotate, each radial line from the center represents 15 degrees. Some graph paper has more, some has less. It just depends. Okay, so first thing we want to make sure we can identify is which number is r and which number is theta. In that coordinate, which number is r? Yeah? 3. And that means the theta is the 45. That's r, that's theta. So, the r tells me to start at the origin and go which way, how many units? Yeah. We're going to go right 3. So 1, 2, 3. That's not our answer. That's just where we're going to start our rotation from. So we go right 3. And then how many degrees are we going to rotate? Yeah. We're going to rotate 45. And in which direction? Counterclockwise, yeah. So we're going to go right 3, rotate 45 degrees. So 45 degrees is about halfway, and that's your answer. That's how you graph a point in polar. That's why when I type in the equation r equals 3 on the calculator, essentially what it's doing is graphing 3, comma, everything. Right 3, 1 degree. Right 3, 2 degrees. 3 degrees, 4 degrees, 5 degrees. It's going through every t-step value from 0 to 2 pi. And because it's plotting so many points, they all look connected and it looks like a circle. If I don't plot enough points, it could look like I showed you yesterday, like a diamond, if you only did 4 points, or a hexagon. Depends on how many points you plot. Yeah.
So it's kind of like a radar screen where it's able to track one specific object, right? But it's using the same like mapping system?
Possibly. I'm not 100% sure with the coordinate system they use. I don't know.
I think they, like from what it looks like, they use polar because it tracks it on a major ring,
Yeah.
on a
So
radius from the...
yeah, the rings might represent the distance from you, and then the bearing to the object or something like that. Yeah. Okay. So let's try negative 275 degrees. Okay. What's my first step to graph that one? Yeah.
You need to find out which direction to move the origin. So
Okay.
r is negative 2, so you move left 2 from the origin.
Okay, so we're going to go left 2. So we're going to start from right there. And then how many degrees am I going to rotate? Where?
75.
75. And which way?
So would it be down? Because like you're going from the point, right? So clock or counterclockwise.
Counterclockwise, yeah. So we're going to go left 2, and then we're going to rotate counterclockwise 75 degrees. So that's not quite the whole quadrant. It's most of it. So I would put your answer like, you're right about there. So left 2, and then rotate 75 degrees. Any question on that one? So the first one was a positive radius, positive angle. That was a negative radius, positive angle. Let's try positive radius, negative angle. Okay. So what's my first step on this one? Yeah, Ryan?
I think you have to identify r and theta, so r would be 3.
Yep.
And theta would be 60 degrees. So you'd want to go right 3.
So we're going to go right 3, okay.
And you'd want to go clockwise 60.
Yeah, so right 3, and then we're going clockwise 60 degrees. So 60 degrees is 2/3 of the way through the quadrant. So not quite as much as the 75, but definitely a little bit more than half. And that's where you would end up. Okay, so right 3, clockwise 60 degrees. On the test, there will be those radial lines, so it'll be a little easier to figure out exactly where your angle should be. Any questions on that one? All right. So let's try this one. So now this is the last combination you could have. We did positive, positive, negative, positive, positive, negative. This is negative, negative. All right. What's my first step for this one?
Well, first first you have to discern R, so you go, so since it's negative, you go 4 to the left, right?
Okay, we're gonna go 4 to the left, so 1, 2, 3, 4, right there. Okay. And then what
You have
after
to
that?
discern theta, but theta is in radians this time, so that doesn't change much.
Nope.
So you go clockwise 3 pi over 2.
We're gonna go clockwise 3 pi over 2, clockwise because it's negative. And how much is, if I go clockwise 3 pi over 2, where is that gonna land me?
So it should be 120 degrees.
No, not 120. Yep.
Wouldn't it be at the 270?
Yeah, it would be where at the bottom. So you're gonna go, I'm gonna draw this one out because I wanna show you something. You're gonna go left 3, or left 4, and then you're gonna go around, and you land right there. Okay, so that's the first one. And what I'm gonna do, I wanna go like this. Okay. Now, let's do, this one. Can somebody give me a different way to get to that coordinate besides -4, -3 pi over 2? Yep.
Negative 490.
-4, okay. And then because it's radians, can you just translate that for me?
Half pi.
Half of pi. Yeah. So left 4, pi over 2. There's a second way to get to that point. How about third way? Yep.
Can you just do 4 and negative pi over 2?
Yep. You can do 4, that's like this, and then negative pi over 2. There's a third way. And one more. Yep.
3 pi over 2.
4, 3 pi over 2. So how many different ways are there to get to that point?
4.
Yeah, there's 4 different ways. You can go right and then clockwise or counterclockwise, or you can go left, clockwise or counterclockwise. So generally, there are 4 different ways to get to a point. I'm going to say up to 4 ways. Because there's not always 4. If you land on the polar axis, like let's say you had a point right there. Well, you can go right, but then there's no rotation clockwise or counterclockwise. So the angle would just be a 0. So there is no other way when you go right to get to it. You just right and stop. But you could go right and stop, left and rotate that way, left and rotate that way. So there are 3. All right, so generally in polar, every point has a minimum of 3 and up to 4, maximum 4. Now, if you're thinking, well, what about if you go like right and then go around once, go around twice and then stop? Well, it's not really a different way. That's still right counterclockwise. I don't care if you go counterclockwise 7 times and then stop. You still went counterclockwise. Okay.
And even if you went right clockwise, it's still the same answer anyways.
Yeah. All right, so there's up to 4 ways. I also don't count writing each of those in degrees and radians as different ways. Again, it's all based on the direction. If you want to use degrees or radians, that depends on the problem. But it's right clockwise, right counter, left clockwise, left counter. Those are the 4 ways. Now, if you compare that to something like, I have a rectangular grid up here, but if I can just pull one up real quick. If I want to get to this point right here, what's the coordinate to get to that point?
3, 2.
3, 2. What's another coordinate to get to that point?
Is there another coordinate? No.
No?
Yeah, so the value of -3, 2.
Well, that's still 3, 2, yeah. So is there another coordinate to get to that point?
No.
No, in rectangular, it's kind of like, it's a one-to-one mapping, right? Each point has exactly one way to get to it. Right? You cannot get to that point unless you specify exactly right 3 up 2. So that's a big difference between rectangular and polar. So that'll come up when we start converting between rectangular and polar. You may get, when you do a problem, an answer like this. And I may say on the test, I want your answer like that. I want a positive radius and a positive angle. Okay, so you just have to know how to change it. I think the easiest way is just visually. You can graph your point and look at it. I don't know. However you want to do it. Knowing that you can add 2 pi to an angle to make a negative angle positive, you could use that fact to help you as well. Let's look at this one. How about 0, comma, pi? How do we graph that one? Yeah.
It's just a point at the origin.
Right, it's just at the origin, but how much rotation is there?
Technically, pi rotation.
Pi, yeah.
180 degrees.
So what you got to do is you got to put your point like that, and then you take it and you rotate it 180, just like that. And rotate. Okay, it just stays in place. So whenever you have 0, comma something, it just pivots in place. That angle doesn't make a difference. Right? It's always at the origin. Now, if we reverse it and put the 0 in the second spot, is that going to be at the origin?
No.
No. That's going to be where?
In between
Polar
racks.
axis.
It's going to be on the polar axis. So anytime the angle is 0, you end up on the polar axis. Could be left, could be right, but you're on the polar axis somewhere. And just like regular coordinates, you can go in between. If you're 2.5, go out 2.5. Okay, so any questions on the graphing or writing polar coordinates in different ways? Okay. Just another one that's the same. I already pointed that out to you. So when you graph in polar, there is more than one way. In fact, up to 4. Some only have 3. So how do we change from polar to rectangular, and then rectangular to polar, and that's it. So let's start with polar to rectangular. First thing we want to make sure we understand is, what do they give you in polar? What do they want you to figure out? Okay. In polar, what are the 2 things called that they give you for a coordinate? They give you the blank and the blank. Yep. They give you the r and they give you the theta. In rectangular, they don't give you an r and a theta. They give you a different way of describing location. They give you an x and a y. So the goal is going to be to come up with a formula that you can plug an r and a theta into and get an x, and then plug into another formula and get a y. Okay, so let's see if we can figure that out. So here's polar graph. I'm just going to put a single point right there. Okay, the r is the distance from that point to the origin. Okay, that's r. And theta is the angle that you rotated to get to that point. Okay. If you want to describe that point on a Cartesian system, you need to give me 2 numbers. And we just said the 2 numbers are x and y. What does What does the x describe when you're talking about a location of a coordinate? The x tells you something, yeah?
The distance I can cross.
Can you be more specific?
The distance of 0 horizontally.
Oh yeah, it's the horizontal position of the coordinate, either left or right. Yeah. And what does the y tell you? Yeah.
The vertical position?
Yeah, it's the vertical position of the point, either up or down. So in order to describe where that point is on a rectangular coordinate system, I need to know how far up it is from the axis, and I need to know how far over. How far over we go, that's going to be the x part, and how far up we go is going to be the y part. So now they're going to give you these two things in the coordinate, and you have to solve for x and y. Okay, let's start with x. What would be a formula we could use to calculate x, which is the base of that triangle, using the r and the theta? Yep.
R cosine theta equals x.
Yeah. So r cosine theta, just looking kind of familiar, maybe from yesterday. And in this right triangle, what would be the formula to calculate the height of it, which is the y value of the coordinate? Yep.
R sine theta.
Yep. R sine theta. These are the two formulas you use to convert from polar to rectangular. You fill in the r and the theta into the top one, you'll get x. Fill in r and theta into the bottom one, and you will get y. Now, there's a trig function here that we didn't use, that we use quite a bit. What function did we use? Yeah.
Tangent.
We didn't use tangent, and that's because tangent is when you want to go the other way. And we'll talk about that next. There's also something else we didn't use here that we use a lot when we have this kind of shape. Something else, yeah? I didn't use Pythagorean theorem, because Pythagorean theorem is when you know the x and the y, and you want to find the length of the r. That's going the other way. So we'll look at both of those in a minute. All right, so let's try 2, let's do negative 210. I changed it to negative 210 because I wanted it to be a multiple of 30 for the first one. When something is a multiple of 30 or 45, they might ask for an exact answer. Okay, so we're going to have to remember our values from the unit circle. All right, so let's start with x. If I fill in the information from my coordinate into the formula for x, what is my expression going to look like on the right side? Yep.
2 cosine and negative 210.
2 cosine negative 210. And what about my expression for y? Yep. 2 sine negative 210. So this is going to be 2 times something, and that's also going to be 2 times something. I want to figure out what goes in these parentheses. Because that number is a multiple of 30, I want an exact answer. Okay. A decimal is okay if it's exact. A decimal is not okay if it's rounded. So let's start with cosine of negative 210 degrees. Okay, so make sure we change that to degrees. Okay, so cosine negative 210. Let's try again. Cosine negative 210. Okay, so that is a special number, 0.866. What? Well, it's negative, but what is negative 0.866 from our unit circle?
3 over 2, so that's negative root 3 over 2.
That is negative root 3 over 2. Okay, we need to know that. Okay, so that's negative root 3 over 2. So we'll put that in right there. Now, when you're doing a 30, if one of them comes out with a root, the other one will not. Okay, so if we do sine negative 210, we're going to get a nice answer. And that's going to be negative a half. No, positive. Oh, because it's negative, it's going the other way. I think I was thinking of 210, which is negative a half. Yeah, sorry. So the sign of negative 210 is positive 1/2. Decimal's okay if you want to write that there because that's exact. Right? If you want to put a fraction, you could do that as well. Okay, so now let's write our coordinate, completely simplified. What's 2 times negative root 3 over 2? Oh. Nick, what's 2 times negative root 3 over 2? Yep, just negative root 3. And what's 2 times a half? 1. There you go. That is the exact answer when you convert that point in polar to rectangular. If you want it as a decimal, you could also do negative 1.73, comma 1. Okay. Any question on that one? Okay, so what I want to do now is show you how I can check that. You can't do this in your notes, but it's kind of neat on the smartboard. I'm going to graph the point 2, negative 210. So that's 2 units to the right, and then 210 degrees clockwise. Okay. Well, that's 180. And then to get to 210, how much past 180 is 210? Yep, 30 more. 15, 15. Okay. Everybody agree that I put that in the correct spot? Right? 210. So now, what I'm going to do is I'm going to change the background behind that point. I'm going to change it to rectangular. And the background that I'm going to use is the same scale as the polar. It's going to have vertical lines right there. I'm sorry, yeah. The vertical lines will go through all of those tick marks, and the horizontal lines on the grid are going to go through those tick marks. If I did it right, it should look like this point is almost 2 units left and exactly 1 unit up. So let's see. Does that look like it's almost 2 units left and exactly 1 unit up?
Yes.
Yeah. And that only worked because now you can see where I put those little tick marks. They lined up with the polar graph paper. It's the same scale paper. So that's the polar version, and there's the rectangular version. I wait all year to do that. That's pretty cool. Yeah, I figured that out. All right, let's try one that's you don't round. All right, let's try one you do round. We just did one where you don't. Let's do 3, 40 degrees. And there's nothing special about that. It's not a multiple of 30. It's not a multiple of 45. So you're not going to be able to get an exact answer. What's your formula to calculate the x value? What are you going to type in on the calculator? Yep.
3 cosine 40.
3 cosine 40. Okay, so we'll write that down. And what's the formula to calculate the y value? Yeah. 3 sine 40. Good. So 3 sine 40. Again, if there was multiples of 30 and 45, I wouldn't be doing it all at once like this. I would just be typing in the first part to figure out, is it the root 3 over 2 or is it the 1/2? Those are the only numbers you have to worry about with the 30, multiples of 30. Okay. So this is we'll call it 2.30, 1.93. Polar, rectangular. There is one other special number that could pop up because we didn't do a multiple of 45. And that would be if you had something like that. What's 0.707? As an exact fraction. Unit circle is very important if you take calculus to have it like memorized. Yeah.
Root 2 over 10.
That is root 2 over 2. Yeah, so root 2 over 2. All right, so that is another special one that you could see if your angle is a multiple of 45. Okay, so those are the only two ones you got to worry about. Multiples of 30, multiples of 45 for exact answers. All right, so that is polar to rectangular. Now, let's reverse it and do it the other way. Okay, so in rectangular, what is it that they're going to provide you with? Yeah?
They're going to provide with an x, y, and maybe a switch to an r theta.
Yeah, they're going to give you the x and the y, and now you have to find the r and the theta. So I drew the same kind of diagram we had before. The difference is what you know. This time, you're going to know this, and you're going to know that. If you know the x and the y, how could you figure out the r? We kind of mentioned it already. R is the distance from the origin to the point. Yep.
It would be square root of x squared plus y squared.
Yeah, it would be r squared equals x squared plus y squared, or when you solve for r, it's the square root of x squared plus y squared. It's just Pythagorean theorem. Okay. And how would you figure out the amount of rotation? How would you figure out that angle right there? Jeff, how would I figure out that angle? We got to pull from our extensive background of trigonometric knowledge that I imparted to you in the last 3 chapters. How do you solve for an angle in a right triangle? Think about what position is this side relative to that angle.
Y over x.
Well, we need a trig function though. So that's where the positions of the sides are going to come in. What's the position of this side?
Would be cosine x over.
No, not cosine. Is this opposite, adjacent, or hypotenuse?
It's adjacent.
It's adjacent. What about y?
It's opposite.
That's opposite. What's the trig function that has opposite and adjacent in it?
Tangent.
Tangent. Yep. So we would set it up as tangent of our angle equals, and what would go on the other side? Yep. Y over x. Now that's not exactly what we want. We want theta. We don't want tan theta. So what are we going to do to get a formula for just theta? Yep.
Take the inverse tangent of both sides.
Take the inverse tangent of both sides. And now, this question goes back a little bit. But when we talked about inverse trig functions, we had to limit them so that they were functions. Does anybody remember when we talk about, you can either think of it as regular tangent or inverse, but when you talk about regular tangent, we limited the domain. Right? By limiting the domain of regular tangent, we limited the range of inverse tangent. I need to know what that limit is. What was the limit on the domain of regular tangent? And if you don't do this limit, it fails the horizontal line test, right? Because that's what your tangents look like.
Yeah.
So we focused on one section. I need to know the section that we focused on. Yeah.
0 to pi.
When we dealt with inverse cosine, we did 0 to pi. Yep.
Negative pi over 2 to pi over 2.
Negative pi over 2 to pi over 2. That means inverse tangent will only give you an answer from negative pi over 2 to positive pi over 2. What quadrants does that cover? Negative pi over 2 to positive pi over 2. Yeah?
Only one. Only quadrant one.
Well, that's 0 to pi over 2. But we've got negative
Oh,
pi over 2
and
to
4.
pi over 2. Yeah. It covers 1 and 4. So the problem with inverse tangent is it only works on that half of the circle. If we wanted to get answers on the other half, we would have to add something to that. What could we add that would shift all of the answers on this half over to answers on the other half? Yeah?
Make it negative so it's an inverse.
No, what could we add? We have to add something.
An inverse side, and then inverse.
Oh, add a negative. I'm thinking you actually have to add like arithmetic, a number.
Oh.
Yeah, sorry, I wasn't clear with that. Yeah, you have to add a number to that to make all the answers basically shift to the other half. Yeah.
Plus pi.
Plus pi if you're in radians, or plus 180 if you're in degrees. So knowing the quadrant that you're in is important because that's going to change the formula you use to find the angle. If you're in quadrants 1 and 4, you just use inverse tangent y over x. That works perfect because inverse tangent always gives you an answer between negative 90 and 90. If you want to get an answer in quadrants 2 or 3, you have to add 180 to the inverse tangent
Can you scroll
of y
back up?
over x.
Thank you.
Or you can either pi or 180, depends if you're working in radians or you're working in degrees. Now that still doesn't cover everywhere the angle could be. What other situation could come up with your angle besides what's on the board right now? Yeah?
On an axis.
You could be on an axis. If you're on an axis, you just have to memorize the answers either 0, 90, 180, or 270. Why? Well, think about the x value of that point. The x value is 0. You can't plug in an x value of 0 into that formula. Divided by 0. Okay, so that covers everything we need to know to find our angle. And then the radius, well, that's easier because it's just Pythagorean theorem, and it's the same formula in every quadrant, which is x squared plus y squared equals r squared. Okay, so this is converting from rectangular to polar. All right, and let's try this one. You can find r or theta first. They're completely independent, so it doesn't matter which one we do first. Let's do r first. Okay. Make sure we still remember. What's my x value in that coordinate? X value, yep. So that's my x. -5 is my y. Fill them in and use Pythagorean theorem to find the hypotenuse of your triangle, which is the radius of your point. So we're going to have the square root of 3 squared. You know what? I'll write it out so you can see it. 3 squared and negative 5 squared. That's going to give me a radius of square root of, yep,
34.
34. Okay, so there's your radius and your angle. What quadrant are we in?
Quadrant 1.
3.
Nope, not quadrant 1. We're right and we're down.
4.
We're in quadrant 4. What's your formula to find theta in quadrant 4? Yep.
Inverse tan xy.
Inverse tangent
Or y divided by x.
y divided by x. Right, so second, inverse tangent, y divided by x. They didn't say whether to be radians or degrees. You're not going to get a nice answer no matter which way you do it. If you are going to get a nice answer, do it in degrees first, and then change it by hand to radians. We get an angle of negative 59.04.
So that is clockwise.
So that is writing your angle going clockwise, yes. So your final answer, or one way to write it, is r, comma, theta. How many other ways are there to write that angle? In addition to that one, there's 3. Yeah. So I could ask for any of the other 3 answers. And the way I would generally say it is, like if I wanted it a certain way, I'd say make your radius and your angle positive numbers. That's
That would be.
You just add 360 to that. Yeah.
So that'd be like 301.96.
Yeah, somewhere right around there. Yeah. Okay, so that's the first part on polar. Tomorrow, we're going to tie that in with parametric, and we're going to do some graphing. So homework is on the board.